In this demo, we use generative AI for sophisticated network vulnerability discovery. All right, to get started in my demo, I have a couple of files open in Visual Studio Code. I have WD, which stands for wired, _vulnerability _with _follow-up. So that's wired vulnerability with follow-up. And I also have GPT-3 Nmap scanning. Now this script uses a GPT-3 model, and we're going to be using GPT-4 with the newer vulnerability scan. I've also included OpenAI API key.txt just to remind that we set an OpenAI _API _key environment variable, and we'll be using that when we interact with the OpenAI API. Okay, so back to wired vulnerability with follow-up. Let's examine this code. On lines 4 through 6, we're importing the libraries and classes that we need. And this is one difference that we have versus the GPT-3 model. In line 4, we're importing the OpenAI class from the OpenAI module. In the GPT-3 script, we simply imported the OpenAI module. Okay, now further on line 5, we'll be using Nmap to perform our vulnerability scan. And then we import sys. We'll be using that in a loop that we're using later on. Okay, so another difference is that we're going to instantiate a client object like we're doing on line 11, and that will interact with the OpenAI API. That is why we imported the OpenAI class on line 4. Note also that if no API key argument is explicitly specified, then the OpenAI class will attempt to retrieve the API key from an environment variable named OpenAI _API _key, exactly as we specified earlier. So we don't have to specify anything here. And in fact, on line 11, we haven't specified any API key. It's going to extract it from the environment variable. Otherwise, we could specify the API key and pass it as a parameter when we instantiated the client object. Okay, so scrolling down, and notice I've got a fair amount of comments here, and that's because there are quite a few changes between GPT-3 and the GPT-4 models when interacting with the OpenAI API. So it's as simple as this. The GPT-3 model that we used earlier uses the completions API, whereas GPT-4 only supports the chat API. And there are some major differences going on here. Let's go over to the GPT-3 script one more time. Notice that when we define the function that calls the OpenAI API, we pass a query, okay, and then we make a call to create. And this no longer works with GPT-4. We specify as a parameter the engine, that's a GPT-3 variant, and with the previous model, when we wanted to query the GPT model, we specified that in a prompt parameter, as shown on line 13. Okay, back to the wired vulnerability with follow-up script. Okay, so in our function definition on line 20, we specify two parameters, previous messages and new user message, and new user message has a default of none. Then on line 21, I'm checking to see if there is a new user message, and if there is, then I'm appending it to previous messages, and that way we'll keep track of the messages that we're sending to the GPT-4 model. Okay, now newer versions of the OpenAI Python API library don't support the chat completion attribute anymore. They did at one point. But the newer API client has a chat attribute and a method completions.create. And this is what's used to interact with OpenAI's chat-based models like GPT-4. And note on line 24, when I make the call to completions.create, I specify a model, not an engine, GPT-4 on line 25. Then instead of prompt, we specify messages, a list of messages that makes up the conversation with the GPT model, and it supports multi-turn queries. What this does is it allows us to maintain context and continuity throughout an interactive session with the GPT model. Now, one other parameter that I want you to be aware of, on line 27, we set the temperature at 1, so that's about halfway. And then on line 28, max tokens, this defaults to infinity. So it's a good idea to set it at a reasonable value, so I set it at 500. So again, this is quite a bit different than GPT-3 that we've used earlier. Okay, on line 30, we return the response, and we also return previous messages because, again, we want to keep track of the messages and be able to accumulate them so that we maintain context and continuity throughout our interactive session. Okay, lines 32 down through 47, we're essentially doing the scan, the vulnerability scan using Nmap port scanner, and then we're formatting the scan results. Then on line 49, I define another function, print analysis, and I pass it response, and it's essentially just going to extract and print the analysis message from the chat response. Now, on line 56, I specify a variable, previous messages. So this is my list of messages. So you essentially specify a role, and on line 57, the role is system. So this is for the GPT model. Then for content, I specify you are a master cybersecurity analyst and researcher. On line 58, the role is user, so that's me, and I'm specifying the content to send to the GPT model. Analyze these results from an Nmap scan and give me some recommended exploits, including CVE numbers for reference. Then on line 59, I specify another message. The role is user again, and the content is the recon info that we got from the Nmap vulnerability scan. Okay, line 63, this is where I make the call to start chat session. I have two values that are going to be returned, recon_analysis and previous messages, and I pass previous messages as well. On line 66, I make a call to the print analysis function, and I pass recon analysis. And on line 69, I set up to allow for follow-up questions. So essentially, if I have a follow-up question, I can type it. Otherwise, I type exit, and that will end the session. Now, line 71, that's the start of the loop. While true, on line 72, follow-up equals, and I'm using input to get a follow-up question from the user. On line 74, if follow-up is exit, then I'll exit the session with an exit code of 0. On line 79, I have two values that are going to be returned, recon analysis. This is the new recon analysis based on the follow-up question, and previous messages. And then I pass in previous messages and follow-up. So follow-up, if we go back up to our function definition, follow-up is being passed in, and it will end up being the new user message. Okay, finally, on line 82, I print the analysis. Okay, so the first thing that you might want to do is just check the version of the OpenAI module that you have installed, or just directly upgrade it. So I'll type pip install -- upgrade OpenAI, and I right arrowed to autocomplete. Now, if I type pip show OpenAI, it shows that I have version 1.1.1 installed. Okay, so now let's make the terminal quite a bit bigger, and let's run the script. So I'll type Python wd vulnerability with followup.py. I'll autocomplete with the right arrow key and press enter. Now this is doing a scan on the entire 192.168.100.0/24 subnet. So it may take up to a minute or maybe a little bit longer. Depends on how many devices you have on your network and their complexity and so on. Okay, and there is our analysis. We have 3 hosts in total that it was able to identify. 192.168.100.1. This is basically associated with my VMware server. I use VMware for my virtual machines. We have a second host, 192.168.100.128. This has a couple of ports open, but the one that I find interesting is 100.140. So this has an RDP port open, and it also has port 5900 open. Notice that it references the CVEs describing the vulnerabilities associated with these open ports and their services. Okay, and notice at the bottom of the screen, if you have a follow-up question, type it now. Otherwise, type exit to end the session. So I'm going to specify a follow-up question. I'm going to ask about port 5900. I know that's a VNC port. So I'm going to ask it, if I know the credentials of 100.140, then I can just connect using a VNC client, right? So to maintain the continuity and the context, it's actually going through the previous messages and it's adding this message. It specifies, yes, if you have valid credentials, you're able to connect directly using a VNC client due to the fact that port 5900 is open. And it mentions, as I'm aware, that port 5900 is the default port for VNC services. And it also reminds me that I need to follow ethical guidelines when performing penetration testing. Now I'll just type exit to exit out of the program. Okay, so with GPT-4 then, we can take advantage of the way that the API is designed to easily allow follow-up messages and multi-turn conversations with the messages parameter. All right then, with that, we've used generative AI to perform a sophisticated network vulnerability scan. In this demo, we'll use generative AI to help monitor and analyze wireless network activity. Okay, to get started in my demo, I have a couple of files open in Visual Studio Code. I have WL, which stands for wireless, _packet_analysis.py open. I've also got synth_WL_packets_mixed.py open. The latter is going to be used to synthesize some packets that we can analyze with GPT-4. So I'll select the second tab. Now this script imports Scapy, and that's the key ingredient in this script. Scapy is a powerful interactive packet manipulation program and library for Python. We're going to import some functions from the Scapy library and use them to synthesize wireless network packets. I'm not going to spend too much time going over the code. It's fairly simple. We import the libraries that we need. We create a list of authorized MAC addresses as well as an unauthorized MAC address. We generate the SSIDs of the network. We create an empty list to hold packets, and then we create the packets in a for loop. We're going to create 10 packets, and one of them, only one of the 10, is going to include an unauthorized MAC address. The work in creating the packets is done on line 28. This is where we use the modules from the Scapy library to create the network packet. Then on line 29, we append each packet to a packets list. At the bottom of the script on line 32, we use WR pcap to write the list of packets to a pcap file or a packet capture file. And we will analyze the network activity from that packet capture file. So let's go to the wireless packet analysis script. Okay, on line 1, I import PyShark. PyShark is a Python wrapper for T-Shark, a network protocol analyzer that's part of the Wireshark project. It allows Python scripts to access and interact with packet data captured by T-Shark. PyShark provides a Pythonic interface to T-Shark's functionality, making it easier to automate analysis, extract fields, and interact with packet captures within Python applications. For this demo, we also need Wireshark installed on the system. When you install Wireshark, T-Shark is also installed as part of the package. PyShark calls T-Shark processes and parses their output. So without T-Shark available on the system, PyShark will not function. Okay, so now for the rest of the code, on line 5, we initialize the OpenAI client, and recall that it's going to grab the OpenAI API key from the environment variable that I've created earlier. On line 7, we define the analyze capture function. We pass in the packet capture file path. Then we load it on line 9 using PyShark file capture. And then starting on line 12, we iterate over each packet and create a summary packet by packet. On line 19, we create a packet summary of an individual packet by using the extracted information from the pcap file. Then we send that data to GPT-4. On line 22, we use the completions.create method, and we specify the GPT-4 model, and our message is include for the system. On line 25, you are an AI that analyzes network traffic, and for the role user, the content, authorized MACs only include, and I include the authorized MAC addresses. And then on line 27, user role again, I'm passing the GPT-4 model the packet summary for this individual packet. Down on line 34, we process the response from GPT-4, and then we print it out on line 35. And of course, line 37 is where we call analyze capture and pass it the pcap file path. Okay, so let's get started. So first, I'll make terminal just a little bit bigger. Now, one thing I would like to bring up is this readme.txt file that I've also included. It contains all the information regarding PyShark, Scapy, and Wireshark, and the OpenAI API key.txt file, just as a reminder that we have this OpenAI API key already configured. Okay, so now down in terminal, I'll type winget search Wireshark, and that shows one software version, and the ID is Wireshark Foundation.Wireshark. So now I'll type winget install Wireshark Foundation.Wireshark, press enter. It notifies us that it found an existing package installed, and I already installed it, of course. So now if I type winget list, that lists all the packages that are installed on this system. The column on the far right is source, and many of these are sourced by winget. So that means that I installed these packages using winget. And if I scroll back down, I'll find Wireshark. And of course, it has been installed using winget. So the next thing is to install the modules that we need for our scripts. And for that, I'll type pip install Scapy space PyShark. And that's both of the modules that we need for this demo. And when I press enter, it's going to tell me that the requirement's already satisfied, of course, because I did install these already. Okay, so now let's run the scripts. First, we'll synthesize some packet capture data. So I'll type Python, start typing synth, and then autocomplete. Okay, so now with the program having run, the packet capture file is created in the current directory. So if I do an ls, notice the mixed_attempts.pcap. That's the file that we just created. Okay, so now let's analyze the network activity in that file. So I'll type Python wl_packet_analysis.py and press enter. And I'll make the terminal a little bit bigger. Okay, and the analysis for packet 1 comes up. And it tells us that this packet is authorized, tells us the source MAC, and that it's a broadcast packet. Packet 2 is similar, it's also authorized. And packet 3, there's the unauthorized packet. Okay, now it continues on till it gets to the end of the packets list, which is packet 10. All right, so using generative AI, we're able to analyze our wireless network activity that we synthesized. To put this into real perspective, imagine if we had a packet capture file that had millions of lines of activity, so millions of packets. We could analyze those packets using generative AI and determine whether there's threats, some vulnerabilities, whether there is an attack going on, the footprint of the attack, and so on. All right, well, with that, we've used generative AI to help monitor and analyze wireless network activity. In this demo, we conduct a simulated generative AI-driven attack on a wired network. Okay, to get started in my demo, I'm on a Kali Linux machine. I've opened my browser and I've navigated to github.com/pvanfas/socialfish, and that's PHISH, socialfish. Socialfish is a very complete phishing tool. It has 32 templates plus one customizable template. We'll use it to generate a fake Instagram login form from which we can harvest the credentials from our target. All right, on the page, I'll expand code. I'll select the copy icon to select the GitHub URL for this repo. Now I have a terminal open. So up on the panel, I'll select my terminal icon to bring up my terminal. And now in terminal, I'll type git clone, I'll right click, and I'll select paste clipboard. And now press enter. Okay, so now that repo has been cloned locally. If I do an ls, notice that I now have a socialfish directory. I'll cd into the socialfish directory, and I'll run the socialfish shell script by typing socialfish.sh. I'll tab to autocomplete and press enter. So as mentioned, there are 32 templates and one custom template. I'll specify 01 for Instagram. For a port forwarding option, I'll specify 01 for servio.net. I'll just leave the default port by pressing enter. And now behind the scenes, it's starting the PHP server. All right, now we're ready to go. So beside send a direct link to target, I'll right click the link and I'll select copy link address. Okay, so now what I've done, I went to ChatGPT, signed in, And I asked it if it could write me an email to inform our users that there's been suspicious activity on their account and that they should log in to confirm that their accounts are okay. And what I got back was beautiful in terms of very convincing, that is. Okay, so far we've generated a form and I've got ChatGPT to write me a very convincing phishing email, although I didn't tell it it was a phishing email. So how do we prevent these types of phishing attacks? Well, one of the best ways is through education. Users should be aware of the tactics and techniques commonly employed in phishing attacks. The more aware they are of these tactics and techniques, the more likely it is that they'll be able to spot phishing attacks or phishing emails like the one that we're about to create here. Okay, so what I did was I took the response that I got, and I'll go to my third tab where I have Gmail open, and I created a template with the content that was generated by ChatGPT. So if I select Compose, first I'll expand my email canvas. Now at the bottom of the canvas, I'll select the More Options icon, and I've enabled templates for this Gmail account. So if I point to templates, under Insert Template, I have one template, Phishing, Urgent, Suspicious. I'll select that one, and that populates the email with the content that I copied from ChatGPT. Let's just clean this up a little bit. So at the very top, I'll remove the forwarding information. Okay, looks good. Now I'm going to scroll down and I'll place my cursor in the hyperlink and I'll select Change. And I'll replace the web address with the social fish link and I'll select OK. Now I'll specify a recipient. My target email is rccsdevops@gmail.com. I'll select Send. Okay, so now my target should get that email. Now I'm going to go over to a second machine where I have my Gmail open, and this is an Ubuntu Linux machine, and the email hasn't quite come in yet, so I'll press refresh. Still nothing. Okay, and there it is. So I'll select the phishing email. So again, if I was a user, educated and aware, I would realize that this is a phishing attack. Okay, so now if I scroll down, I'll click this link. That opens a new tab in my browser with what appears to be a legitimate Instagram login form. Now I'll specify my login information, select login, and of course that doesn't really log me in, it just brings up the real Instagram login form. Now let's go back to my Kali Linux machine. Select the terminal, and lo and behold, I have just harvested the credentials for my target. Okay, so something that we've learned throughout this course and throughout this path is that reusing passwords is really not a great policy. And this is the reason why. So I've just harvested these credentials. Now I've performed a vulnerability scan prior, and I found out that this user's machine has a VNC port open. So now I'm going to try these credentials with a VNC viewer, which comes pre-installed on this version of Kali Linux. Now, if you're not familiar with VNC, it's remote connectivity software that allows you to take over a machine. The machine on the other side, the remote machine, must be running VNC server. VNC servers have port 5900 open. That's the default port for VNC. So I have a VNC viewer on this Kali Linux machine, and I'm going to use it to connect to the remote machine. So I'll type VNC viewer, press enter. Now in the dialog that appears, I'll type 192.168.100.140, and now the password form appears. I'll enter the password that I just harvested from my social phishing attack, press enter, and lo and behold, I now have a VNC connection on my target's machine, which means I have full control over their machine. Okay, so this is where a lot of network and perimeter hacking attacks originate. It's common for attackers to harvest users' credentials and then use their victims' credentials to gain access to the network. Then once inside, they can take their time, stay stealthy, and find the valuable targets that they're looking for. In fact, that's what happened with a famous ransomware attack, the Colonial Pipeline attack in 2021, that shut down an entire pipeline, causing a real disruption to fuel supplies across the eastern United States. All right, and with that, we've conducted a simulated generative AI-driven attack on a wired network.